So good morning everyone, and today we are going to discuss about molecular orbital theory, chemical bonding chapter. The chapter name is chemical bonding, class 11, class 11, chemistry, and the topic is molecular orbital, molecular orbital theory, molecular orbital. Today's date is 30th November 2025. So today's date is 30 November 2025. So here, before explaining the theory, let us have some basic idea for molecular orbital. As I can say here, molecular orbitals, talking about starting, let us take two atomic orbitals. Here AO means atomic orbitals. We know that every element has its own atomic orbitals. So similarly, atomic orbitals have their own comparable energies. They both have their own comparable energies. For example, they both have their own energies. These two energies combine to form a what? Molecular orbital. These two energies combine to form a molecular orbital. Two atomic orbitals combine and they form a molecular orbital. Now, molecular orbital on combination, they can be divided into two parts. First part can be known as BMO and another part is to be known as ABMO. BMO, bonding molecular orbital, ABMO, anti-bonding molecular orbital. Anti-bonding molecular orbital. Now, here we can say that the bonding molecular orbital has energy. Here, the bonding molecular orbital, anti-bonding molecular orbital both has energy. But here, what? The energy is low and it is stable. Here, the energy is high. That is why it is unstable. That is, here the stability is more and here the stability is less in terms of bonding molecular orbital and in terms of anti-bonding molecular orbital. Now, how we can represent a molecular orbital? We can represent a molecular orbital on the basis of an energy level diagram. We can discuss on the basis of an energy level diagram. Talking here as energy level diagram. Energy level diagram can be calculated on the basis of number of electrons. What is the total number of electrons in a molecule? Since we are talking here about a molecule. Starting is, for example, I have taken as n is to be the total number of electrons. And for better understanding, talking here about if n is greater than 40. We have taken as 14 as a basic example. If n is greater than 14, then I can give a basic energy level diagram as like this. here in this diagram, here I can say that if number of electrons is more than 14, then here this kind of energy level diagram can be shown here, where the electrons would be filled according to the Hund's rule of multiplicity and power principle. So also Mulliken's rule will be applied. So here this pi star or sigma star represents the antibonding molecular orbitals. And talking about sigma and pi, they are to be representing the bonding molecular orbitals. Here, this is a basic example of if n is greater than 40. Here we can say that the px orbital is in the lower state. Again, the 2px py is diagram is like this. Now, if n is less than or equal to 40, if n is less than or equal to 40, there is a small change in the diagram which we can show it here, as there will be a small change in the p orbital. There is a change where the 2px orbital and 2py orbital will be in the lower state and the z orbital will be in the upper region. This is two changes where if n is less than or equal to 14 and if n is greater than 14, it was the earlier diagram. I hope you have taken the screenshot of it. Now, for better explanation, let us do an example. For example, we are going to do for C2. Talking here for C2, we know that carbon atomic number is 6, so its electronic configuration is 1s2, 2s2, 2p2. Now here it is for one carbon. Now, but when we are talking for two carbons, it is going to be 12, right? It is going to be 12. So how we are going to represent? First, talking about the 1s for both the carbons. This is carbon C1, this is carbon C2. This is carbon C1 and this is carbon C2. Again for 2s. Here you might have a similarity of diagram between this and this, because here also if it is 12, then it is number of electron is less than or equal to 14, so it is less. That is why I have made this diagram. Now talking about this is 2p orbital. Here it is sigma 1s, here it is sigma star 1s, that is antibonding. Again here it is sigma 2s, here it is sigma star 2s. It is pi 2px, here it is pi 2py, here it is pi 2pz, here it is pi star 2px, here it is pi star 2py, here it is pi star 2pz. So now placement of the or the filling of the orbitals with the electrons, here we can show that, for example, carbon has 2, so for one carbon it is 1, again from second carbon it is 2, again for one is for here, and again second is for this. So here it becomes 1 from each carbon. Now talking about the second orbital, again here it is 2, and so similarly the carbon 2 is also 1s2, 2s2 and 2p2. So again 1 from this carbon, again 2, then again this carbon 1 and this again 2. Now we should also remember that the total electrons number is 12. So here it is 2, 4, 6 and 8. So we have done till now 8 electrons we have got, and we have left with how many electrons? 4. So now again, for talking about, if we go for p orbital, then I can say that one will be here, and again this orbital has also one electron here. So one is here, and again from another one here. Now more 2, again here, right? So whether they are filled. Now talking about 2, 4, 6, 8, 10, 12. This is how we can show for C2, that is carbon 2. Now apart from this energy level diagram, we can also calculate the bond order. Bond order formula, for the calculation of bond order, the formula is bonding molecular orbital minus anti-bonding molecular orbital divided by 2. Now just now I have said you earlier in the video that pi star and sigma star represents anti-bonding and pi and sigma represents bonding molecular orbital. So if we count the bonding molecular orbital as 2, 4, 6 and 8. So the bonding molecular orbital is 8. What about the anti-bonding? Star is 2, again 2 star is 4. So it's 4 divided by 2. So what would be? The answer is 2. So this is how we can calculate the bonding order of a molecule. That is, bond order of a molecule can be calculated upon this formula. And also there is one more formula. If I can say we are in a hurry in the examination, so we can say directly as 2 minus 2, that is they are cancelling each other. 2 minus 2, again 2 minus 2, it's got what is left? 2 and 2, 4. So again 4 divided by 2 directly is 2. So this is also a formula. Now one more thing we should remember, that bond order is inversely proportional to bond length. That if a molecule has a bond order maximum, then its bond length would be less. But if bond length is maximum, then bond order would be less. That is vice versa. So this is how we calculate the energy level diagram for a molecule, and it is due to the molecular orbital theory. And now I would like you to give an assignment for making energy level diagram for N2, that is very common in the examinations, and O2 to negative. Please prepare and try to complete it as soon as possible, and if you have any doubt, then you can comment it in the comment section, that wherever you have not understood the video, so that I can explain to you once more. Thank you.